right, so we're going to finish off with the bone function of bones. Bones support, maintain our upright body. They protect our organs, like the ribs can protect our heart and lungs. Our vertebrae protect our spinal cord. And the bones are made up of either compact bone or spongy bone. And they each have a different orientation or a different arrangement in the bones. But if we were to look at a long bone, the diaphysis is the long shaft, and the ends, the wider ends, are called the epiphyses. And the diaphysis contains a medullary cavity, which is a hollow cavity which contains mostly yellow marrow, which is mostly fat. Originally in children, it's red marrow, and then as we become adults, it turns into yellow marrow. And the epiphyses at the end, they contain the red bone marrow that is used to produce red blood cells. And at where the diaphysis and the epiphysis meet is our growth plate, and that's where our bones get longer and new bone grows, and eventually this closes off as we become adults and turns into the epiphyseal line. The bone is covered with what's strong connective tissue, which is called periosteum, and that contains there's a dense blood supply and nerves in the periosteum, and also our ligaments come off of the periosteum. And so throughout our life, our skeleton is constantly changing. And we have what are called osteoblasts and osteoclasts. Osteoclasts are, they dissolve and absorb bone. So if we have areas that are breaking down, the osteoclasts will absorb the bone, and then osteoblasts will lay down new bone. And this process of reshaping is due to Wolff's law, which means the bone will respond to the type of stresses that are applied to the bone. So if we have bone that's constantly, demands are being put on it, it will lay down more osteoblasts and bone matrix and make a stronger bone, as opposed to a more sedentary lifestyle. The bone will not be as strong. So Wolff's law is just the bone will respond to the type of stress that is applied to it. And so this is just a picture, and you'll see the compact bone lays on the surface of the entire bone, but in the epiphysis contains that spongy bone where we see the red bone marrow. And then the center core is the medullary cavity that contains a lot of our rich blood supply. And this just shows all the different bones of the body. And we break our skeleton up into what we call the axial and the appendicular skeleton. The axial skeleton is the skull, the breastbone, the ribs, and the vertebrae. And it's more protective. And the vertebral column, we have different areas with different arches. The cervical are the top 7 vertebrae. They're usually finer vertebrae. And then the thoracic vertebrae are what the ribs attach to. The lumbar vertebrae are usually, there's 5 of those, and they're usually stronger, thicker, and because they bear so much weight. And then the sacrum is fused vertebrae, and that's where our vertebrae connects with our pelvis. And then the following last vertebrae are fused are the coccyx, and those are the remnants of a tailbone. So the appendicular skeleton are the bones of our arms and our legs, our shoulder girdle, and our hips, or our pelvic girdle. And that's where our appendicular skeleton attaches to the axial skeleton at the shoulder and the pelvic girdle. And so we have Where two bones come together, we call that a joint, and the two bones articulate with each other and or come in contact with each other. And there's different types of joints. A fibrous joint is an immovable joint. Those are the joints between the bones in our skull, and they usually become fixed as we age. Cartilaginous joints are usually considered to have low or no movement, and an example of those is where the pubic bones in your pelvis meet, or the bones where your ribs, or the cartilage where your ribs comes and makes contact with your sternum. And then synovial joints are freely movable joints. So those are the joints of your shoulder and your hips, your knees. And to these types of joints, there's four characteristics. They have articular cartilage, which covers the ends of the bones where they meet, and that's just to make a smooth surface. They're encapsulated with an articular capsule, which is a sleeve around the two bones, bringing them together. And then inside this articular capsule is synovial membrane, which secretes what's called a synovial fluid, which makes it's like a jelly, and it allows smooth movement of the bones. So here you can see the periosteum, which covers bones, is the origin of ligaments that hold the two bone ends together, as well as it is the origin of the capsule that sleeves or encapsulates the two bones. And you can also see the synovial membrane in the green releases the synovial fluid, and then the blue covering the ends of the bone is the articular cartilage. And so osteoporosis is when bones become weak or brittle. They're not as strong, so they're more susceptible to breaking. It has a large part due to our calcium, where our bones are constantly pulling calcium from our bones or depositing calcium. And exercise and good nutrition, good diet with calcium intake helps to prevent osteoporosis. Exercise puts stress on the bones, and with Wolff's Law, a bone will adapt to those increased stresses placed on it. And so resistance training, weight-bearing exercise, running, playing basketball, those things all increase the strength of the bone matrix and the strength of the bone. And ligaments are just a connective tissue that originates from the periosteum, that is the connective tissue that covers bone, and it just connects two bones together. And then the tendon, as we talked about before, is where it attaches muscle to bone. So they're similar in that they're both this dense fibrous connective tissue. But the tendon does contain a little more collagen for added strength, and the ligaments have this elastin, which allows more stretch in the joint.